Okay, so this is kind of the second half of lecture 3. It was on January 18th. And so here I'm going to talk about something called block diagrams and timing diagrams. And these are going to be useful tools to analyze and think about circuits. So let's go ahead and think about the AND gate, which I've already drawn one up here. And all an AND gate is doing, right, is taking A and B and puts a true on the output. I'm going to use F again if both A and B are 1. But what happens if I want a 4-input AND gate, right? I've drawn these before. And I want to make that. Well, the way that this is going to work is I can build this out of 2-input AND gates. So let's just take another AND gate. Add a third AND gate. And I'm not going to name this F anymore because that'll be confusing. I'm going to just call it Z. We're going to skip to the end of the alphabet, okay? A, B, C, D. These two are equivalent, right? Because if I write the expression for Z, Z is equal to A and B and C and D, right? Because this is A and B, this is C and D. But because multiplication is what it factors through, right? We're not going to get into the technicalities of it, but this multiplication that I drew out explicitly isn't needed. It's just A, B, C, D, A and B and C and D, which the output is going to be true if all of those inputs are all 1, and only if that's true. So I've built a 4-input AND gate. So that 4-input AND gate here represents that complicated, well, more complicated circuit. What happens if I want an 8? I'm going to draw this even bigger than it is because it's going to come back around to us. So let's draw a nice big 8-input AND gate. Okay. Well, I can build that using 4-input AND gates really easily. Right? So here's a 2, here's a 4, here's a 4. I'm good to go. This circuit is inside of that circuit, right? That's what a block diagram means. When I say block diagram, I mean I'm going to have this larger block. Sometimes it's going to be a square, sometimes it's not, of a circuit that's going to represent something more complicated than it might look, right? And you can build each of these and build them up, but understand the inside of this 8-input AND gate is really, well, there's one AND gate. Let's go ahead and do this with red. There's one AND gate right here. There are there are 3 inside of the 4-input and 3 inside of that 4-input. That makes for a total of 7 AND gates to build the big 8-input AND gate. So this block diagram is a way of abstracting the design, and so you can draw it easier than might be really complicated, because drawing this out with all 7 AND gates would be obnoxious. Okay, but there's something more to this that I want to talk about. So let's say that in this 4-input at the top, this is called A, this is called B, this is C, and that's D. Now, there's 2 different concepts here that I need you to differentiate, which is there are the signals that are the inputs and the outputs. So in the first top left, there is signal A, signal B, signal C, signal D. Then there are these connecting signals that are A and B. Let's give A and B a name of Q and C and D a name of R. We're just going to intermediate variables. What you'll see is inside of the block diagram of the 4-input, we don't see Q or R. What we see is A, B, C, and D. But those aren't signals anymore. Inside of that block, they're signals. But to the outside world, they're what's called ports. They're something that you can plug up to. And I don't have to call the signal that plugs into it the same as what the port is. So let's go over and look over here, right? And I'm going to use blue for the new stuff because I've labeled those ports. This is port A, this is port B, C, and D. But there's just a new component, A, B, C, D. This is the same 4-input AND gate. Well, the same design, right? But it's a different what we call instance. So this is going to be, we're going to call this U0 and this one U1. It has a name. It's U1, which is a 4-input AND gate, right? And I've used 2 of them. But up here at the, and I'm going to give this guy a name for and 8. That's his name. He's an 8-put AND gate. His name is AND8, and he has 2 4-input AND gates in them that are named U0 and U1. Make sense? Okay, so now where I do this is see that I have these ports A, B, C, D, E, F, G, and H for my input. Now, if we go look at what happens on the input, that means, I'm going to do this in red, that for the first 4-input AND gate, they're all the same. It's A, the signal A is the same as the port A for the 4-input. Down here, however, E, F, G, and H. I have plugged the signal E into port A of U1, right? So port A is where signals go. The ports are where signals plug into versus the signals. And the signal can have a different name than the port. Okay, this is the most complicated part of block diagrams, and I'm not really sure I understand why for students, but I'm going to try and approach this repeatedly, this idea. So just to reiterate, on the inside of the lowest level of the 4-input AND gate, which is circled in green in your top left, I have signals A, B, C, and D. Those become ports when I abstract it to a block diagram called A, B, C, and D. Those ports are connected internally to those signals A, but not, it doesn't have to share the name, right? Because over where I'm about to circle in yellow, this E, F, G, and H, those are signals until I abstract it up higher level and have an 8. And now see this H? This signal H is now this port H. And I can call these signals maybe X0, X1, X2, down to X7, right? This is 0 index, so the highest number is 7. So X7 is a signal connected to H, the port H. Okay. I don't know if this is going to help you guys or not. I'm experimenting here for future reference. So now that we have this idea of ports and internal signals, I can also call, if I didn't want to, see how I've used Q as an internal signal? I can call this Q and this R, and I can plug them up. But remember how I said if they're the same name, then they're connected? But that's not true. When I start abstracting, these variables, these internal signals become local, meaning they're not global. So this block, this AND8, doesn't know, or rather it does, but the outside world doesn't know that there's a signal inside called Q. It only knows that there are signals A through H that you can connect up to using the ports that are also called A through H, right? And so there are signals and there are ports. The signals connect 2 ports together, right? So in the 4-input AND gate, it has this output port. What do I want to call the output port? M. The output port M. That means in U0, the output port is M right here. But this signal is not M. It could be, I could call it M, but remember that the output is M and the input, the 2-input AND gate is A. So I'm connecting M to A through a signal, and I can call that signal S if I wanted. or Q or P or llama. It doesn't really matter, but I need to give it a name, an association that it is connecting the port M to the port A. The port M of U0 to port A of this thing that I've labeled 2, right? It's a signal that's connecting them together. Okay, so that's block diagrams. That's how things connect together. So that when I start talking about it, drawing these abstracted, complicated circuits, we understand that they're being connected in this way with ports and signals, and it's going to scale up to bigger and bigger complex circuits. So that's all block diagrams are. There's going to be one more video right after this one that I'm going to talk about timing diagrams.